Good morning, everyone. So today I'm going to give a topic on radar engineering, that is particularly about radar principles. So the radar principles that are going to be combined with the introduction, radar equation, radar block diagrams, etc. So introduction to radar, that is first what is meant by radar. The actual expansion for that radar is radio detection and ranging. So it is going to detect, as well as from the detection, it is going to determine the range also. So how that detection and ranging is going to be performed is by transmitting the electromagnetic signals. So hence we are mentioning that as electromagnetic system that is used for detecting and locating the objects. So it is going to be operated by transmitting the waveform and analyzing the echo. So two parameters are going to be there, transmitting and receiving. So that's transmitting a waveform, and from the transmitted signal, we are going to receive the receiving signal that is mentioned as echoes. So the key functions are going to be, it can function in darkness, fog, rain, etc. So whatever the climatic change occurs, so for all climatic or weather conditions, it is going to support. So it can measure distance as well as velocities. So the basic components of this is transmitter and receiver. So here, a single antenna that is going to function for both transmission as well as receiving antennas. So in transmitting side, you are going to have a transmitting antenna which is going to emit the electromagnetic signals. And in receiving antenna, it is going to collect and process the reflected signals. So here, the reflected signals are going to be mentioned as the echo signals. And how this is going to be working is, so it is going to emit a signal and the reflected signals are collected back. So signal reflex of objects are going to be collected. So here the objects is also or otherwise called as targets. So here again it is going to measure the time delay, direction, velocity, etc. So the actual function of this radar system is, it is going to have a single antenna which is capable of both transmitting as well as receiving the signals. So this blue line indicates the transmitting signal. So once the object or the targets are present, when the signal is going to be fall on that, it is going to scatter the signal. The signal is going to scatter in all directions. And again, the scattered signals are going to be reflected to the antenna unit. So the orange signals are the reflected signals, which are called as echoes. So transmitting and receiving are going to be done by the same antenna unit. So transmitting antenna and receiving antenna will be present as a single antenna system. So the applications of this are going to be, so for low-level applications, it is going to have the detect of hostile aircraft, guide, anti-craft weapons, and in modern advancements, it is going to have the range, velocity, and position. Advantages are going to be operates in all weather conditions. So this is the actual functioning of the radar unit. So it is going to have both the indoor as well as the outdoor units. So in the outdoor units, we are going to have the antenna systems, which is capable of both transmitting as well as receiving the signals. And it is going to emit the signals in all directions. That is 360 degrees directions. It is going to emit the signals, as well as it is going to collect the emitted signals or the reflected signals. And once the signals are going to be reflected back, that is called as the echo signals, that are going to be processed by several units, and the processed signal final it is going to be displayed in the display unit. So here we are going to have two different types of displays. One is PPI, another one is A scope, and also several displays are there, A scope, B scope, etc. But here we are mentioning about the PPI display unit. So this plan position indicator displays. So in this, the outdoor unit, how the antenna is rotating, likewise, similarly here also it is going to rotate in the display. And whenever the target is found, it is going to be when the radar antenna unit is nearing the target, it is going to be shown in very dark. And if it is moved away, far away from the target, it is going to be disappeared. So this we are going to call it as the blips. So the units where it is going to occur, those are called as the blip systems. So the target form, it is going to occur more dark, and if the target is not present, it is going to be disappeared. So far we have discussed about the single object, which is a stationary object. If considering a movable or moving target, then the antenna unit is going to continuously emit the signals, and based on the targets, again the reflected signals are going to be also continuously reflecting the signals. So the red lines are the emitted signals from the antenna unit, and green signals are the reflected signals from the targets. So from this, we can able to calculate both the distance as well as the velocity also. So calculating the radar range measurement. So here the time period we are considering as TR. So which is the time taken for the pulse to travel to the target as well as return to the antenna system. So both transmitting as well as receiving the signals are considered. So the speed of the light is also considered, that is 3 into 10 power 8 meter per second. So the radar range is given as R equal to C into TR by 2. So here why we are considering divided by 2 is, so here we are calculating both transmitting as well as receiving the signals. So hence we are using the parameter divided by 2. So the range calculation. So if the range is measured in kilometers, that has to be expressed as 0.15 into the TR, time taken for the range calculations. And if it is nautical miles, it is 0.081 into TR microseconds. So the key advantages are accuracy of range measurement, the accurate measurements of calculators, and next practical applications used in all surveillance systems, navigation, surveillance, as well as target tracking, etc. So the important advantage of this radar is going to enable the long range detection. So long range detection is possible. So next is about the radar block diagram. So here we are going to have the antenna unit. So here we are going to particularly focus about the pulse radar. So that emits periodic high energy microwave pulses to detect objects by analyzing the time and characteristics of the returned echoes. So the block diagram, it is going to be having the antenna unit, so transmitting unit and receiving unit. So in transmitting unit, you are going to have the transmitter and pulse modulator. And in receiving unit, you are going to have low noise RF amplifier, mixer, IF amplifier, second detector, etc. So the function of this duplexer is to control or guide the signals. So if it is acting as a transmitter, the antenna is acting as a transmitter, the signals should pass to the antenna unit only. So the signal should not enter into the receiver part. And if it is acting as a receiving signal, the signal should be directly entering to the receiver, not to the transmitter. So to have the waveform directions, it is used as a switch. Like a switch, it will be actionable. So and another important parameter of this duplexer is, since the transmitting signals is of very high range signals, gigahertz signals. So if the signals are entering into the receiver, entire receiver will get damaged. So to avoid that, the duplexer are going to be placed here. So the key components are transmitters that is going to generate high energy pulses. Antenna radiates pulse and collects reflected echoes. Duplexer protects the receiver and manages signal routing. Duplexer protects the receiver and manages signal routing. The receiver is also amplifies and processes return echo. Display, that is going to be having several types of displays.